a lot of the things that are done, processes or procedures, are because somebody heard that somebody else is doing, or is a best practice and is always being done, and he air quotes help. But with the science based background and the data driven background, it is more about, well, can we prove that such and such step, process, or procedure actually works, and not so much does it work before and after the implementation, but does it work as an overall effect?
Welcome to the Poultry Podcast Show. Today I am here with our guest, Dr. Juan DeVillena. Welcome.
Thank you. Thank you very much for the opportunity. I really appreciate it.
I'm really excited to chat with you today about some different topics that kind of revolve around data and food quality and business decisions. But first, I want to hear how did you get to your current position? How did you start in poultry?
Oh Lord, we need an entire podcast for just that part. But long story short, I am from Peru, originally from Lima, Peru. And due to my dad's professional career, we moved a lot. And by accident, I got into food science at the Agriculture University in Lima. And from there, I pursued food science. And again, fast forward, came to America, did a master's at University of Maryland in food microbiology. And fast forward 20 some years, I got my doctorate from Texas Tech University and in food safety. And so ever since I started with my first project after leaving Peru, it's been around chicken. I mean, my first project was on fluoroquinolone resistance of avian isolates from North Georgia, in fact. So here I am 26 years later in the state where my first isolates came from. And so that's how can I end up in this business.
Full circle. You've just made it back home.
Yeah.
Oh, I think the area of food safety, especially from a business component, it's so interesting. But can you tell me just a little bit first about what's the role of data in the entire food safety sector? I know that's a huge topic, but what do you think about in terms of data informing your decisions?
So, I mean, I can take you back to when I started in this business. When you do research, and that's the first thing I touched when I started, all of it is about numbers and confidence intervals. And so, I had that training earlier in my career, but then as I got into the actual business of processing chicken food production, one of the things that you notice is that a lot of the things that are done, processes or procedures, are because somebody heard that somebody else is doing, or is a best practice and is always being done, and he air quotes help. But with the science based background and the data driven background, it is more about, well, can we prove that such and such step, process, or procedure actually works, and not so much does it work before and after the implementation, but does it work as an overall effect? And especially when you talk about food safety, you can't just look at it from the standpoint of I'm going to check, for instance, an intervention, an antimicrobial intervention. You can't just look at it before and after the intervention, because that effect could be small, but it could have a huge impact, on a positive impact in the end product. And so you got to look at it as a whole. But in general, it's a very interesting and very delicate balance, I think, when it comes to data analysis, because data is what we need to be able to prove that something is working or not, and not just because I think it's working, I think it's cleaning it, or I think it's improving it. It needs to be more of, the data shows that it actually works. Now, of course, you can't just say, I'm going to collect 10 samples and make my decision. There's other considerations that I'm pretty sure we'll touch on it as we go through.
At bioMaryU, we go beyond microbiology test results. As a trusted partner with 60 years of expertise, we've developed augmented diagnostics, a revolutionary approach combining core microbiology testing with the latest data and genomic methodologies. We help poultry producers measure and understand salmonella and other pathogens, detecting food safety risks on processed and finished products, and leverage data to make better decisions across the whole production chain. Whether it's USDA, FSIS, and other regulation frames, bioMaryU helps you think 360 and optimize your food safety workflow. Go beyond a test result with bioMaryU. BIOMERUX.
Yeah. So the impact of data is the real time understanding of where you need to take samples to get those critical decisions. It sounds like it's not a single yes, no, pass, green light sort of thing.
That's right.
So what do you find to be the most valuable data sets then, just kind of in a big picture?
Yeah, so I got to go back also to our typical, and again, nothing against Excel, but when you look at when you look at Excel, you just basically can only analyze two variables affecting one outcome. And so one of the things that even for me has been a paradigm that I had to just break through is that there's lots more than just two variables that are affecting one outcome. And how can you wrap your mind around those variables? It's beyond the human brain. I mean, we can only see, unfortunately, 2-3 variables, and that's about it. But the tools that we have today really help us to see all these other variables. And so in order to see the big picture, the first thing that in my mind you need to do is make sure that you have a protocol that has a hypothesis of what you're trying to prove. Again, going back to my previous answer is we can't just pull 10 samples or pull 15 samples or even say I'm just going to pull 25 or 100 just because it sounds good. We have to have the evidence and the support to understand how much do I need to collect to be able to achieve a confidence interval that I'm comfortable willing with to work with. And so again, we could say, well, yeah, I took a statistics class in school. I took 5 statistics class, but in my mind, something that has helped us is you have to have a statistician or a mathematician in staff to be able to say, look, I'm trying to see the effect of A, B, or C, X, Y, and Z, and I'm willing to accept a 5% error, so 95% confidence interval. So how many samples do I need to collect? And so whether with historical data or readily available data from the industry, that person needs to tell you how much you're supposed to collect. And because again, I want to be able to produce results that I can defend and not just, Bubba told me I had to collect 25 samples. And so again, I go back to the beginning. If you don't set up your process to collect data at the right amount, your conclusions are going to be worthless. And so the other part is what I mentioned, that I never recommend doing a before and after only. And one of the things that some people fail to do, and I've done it in the past too, is where we only think about that one outcome that we have. But you got to think about all the potential outcomes and how many of these variables could have an effect on it. And in terms of what to test, there's a lot of things. So, depending on, if for instance, I'll give you an example. If you are, if you're doing a test on microbiology, you need to decide whether you're testing indicator organisms, pathogens, whether you're going to do a challenge study, depending on what you have. Because in microbiology, one of the things that is impressive is, for instance, if you do a prevalence for salmonella, well, not all the positives are quantifiable, for instance. So you can't just say because you have a 40% incidence of salmonella, you're going to be able to quantify 100% of those. the number is a lot smaller than that. And so in order to do that, again, you need to come up with whether you need to do a challenge study or something else. But either way, whether you're testing an antimicrobial intervention or you're testing a piece of equipment, you got to have the right amount of samples collected to infer your conclusions.
So are there some difficulties with the next step, which is someone has to collect, and process the data? Do you kind of have to make decisions based on if there's something that will be collected in the slaughter facility or on farm? I mean, there's also like a human component too. Like, what's your best advice for actually getting what you think you're supposed to be getting?
Yeah, so that's a great question, because what we try to do is when we have a big study, for instance, something that we try to prove, we don't go all at it from the get-go. We run a small test, if you will, to make sure that we're capable of. So, I mean, I can give you several examples, but one that comes to mind is we were thinking about running this potential test, and we had to collect, what we came up with was 38 samples in one lot. And so on paper, that sounds like, okay, well, let's go ahead and collect 38 samples. Well, a small group of us went to collect those 38 samples and realized that it was impossible. And so then we had to rethink about how do we make sure that we reduce the amount of samples to ensure that we are still at the false negative rate or false positive rate or whatever you're willing to accept. Another one, of course, is going to be financial, because running those small tests are not cheap, and running a bigger test is not cheap either. But one of the things that I feel like we do a good job is that we have this vetting calls before we run into a project, so that everybody understands how we want to collect it, where we want to collect it, and you're not wondering at the end whether this samples came from the right location or the wrong location. And so, but those people are always going to be a factor, because you want to make sure you ensure consistency. And the only way to ensure consistency is to ensure that the same person collects the same samples from every location all the time. And so that sometimes is not possible. But I think when we do the analysis, our statistician, our data analysis group, they consider all those things and make sure that they can collect enough data to kind of offset those errors. And so as an advice, I would say that there's got to be a lot of planning before we run into a big project. I mean, we had some huge projects that we really didn't have much time to complete. But even on those, we talked about it and make sure that we were all in sync, to make sure that, my data analysis group always says, trash in, trash out. And that's true. I mean, if I don't care how much data you collect, but if that was not collected accurately, the results are going to be meaningless,
Yeah. So it sounds like some of the common challenges, I mean, it could be finances, it could be ability to collect the number of samples required, or are there any other common challenges that, in managing the data or determining an outcome? Like, how do you overcome some of these other things?
Yeah. So one of I would jokingly say that I don't have issues analyzing the data because I don't do it.
Yeah.
we have a team. We have a team of brainiacs that do that. But then understanding the data is very important. But the one thing that joking aside, that I think it's important is to understand the biological effects. And so, for instance, in a chicken environment, a lot of the data that we're going to collect, you cannot analyze it by the regular statistic test that you do. I mean, we deal with a lot of what is called non-parametric statistics, because the data is distributed normally, but it's got, for the lack of better scientific term, it's got this crazy behavior, because again, we're dealing with live animals, with live bacteria. And so you do have that consideration. And the other part too is when you run some of this microbial testing, for instance, you got to make sure that you understand the concentrations that you could potentially have in certain locations, because that would affect the dilutions that you'll have to do, the dilution factors that you need to work with. that you have to know that you can't just go in blind with that. And so that would be the other challenge is understanding what those dilution factors are. But the other one is the data. I mean, the data can be very complicated. But one of the things that I'm a box plot lover. So, I just want to see box plots because I truly believe that they give you a true distribution of the data. You can see the actual data points. You can see where the maximum number of data points fall into it. So to me, it gives you a big picture. Now, I'm also open-minded. And so my team comes and shows different ways to present the data, and I'm okay with it. But again, after we do the initial presentation of the data, there's other questions that come up, and usually is what if? What if we see this interaction against something else? And I think the most difficult part for me is to think about all the potential scenarios because, of course, we think in terms of antimicrobial interventions for instance, microbial outcomes if you're testing for Salmonella indicators or any other pathogens. But then the challenge is, what else are we missing? What else did we not think of that you could graph against to see if it's got an effect or not? And one of the things, for instance, I'll give you an example, is you can be testing at the same location over a 2 or 3 week period. But if you don't consider environmental conditions such as the temperature outside, whether it was wet, humid, or windy or whatnot, transportation from the farm to the plant, yard time, feed withdrawal, whatever. If you don't think about all those, you're hitting your head against the wall thinking of why this data is not matching. But if you put all these other variables, you can really see the pattern or the path or the trend. And so that's why, to me, it's important when it comes to data analysis that you're not limited to just one person doing it, but it's a team, and you gotta really, really look at the data with the people that analyze the data, so you can really draw your conclusions. Otherwise, you'll be leaving on the table things that are important, but you missed it just because you didn't think about it. You were thinking in a silo.
Oh gosh, yeah. So how, in the kind of like your experience in the industry, how has testing changed over time, and like what are we doing now to improve just detection and prevention? I mean, it's a big question, but I know stuff has got to have changed because our data sets are getting bigger, more complex, and sounds like you're getting great at understanding nuances.
Yeah, so I think one, in the past, like I said, it was more of let's just run 50 tests or 50. Let's collect 50 samples. Let's collect 100 samples, and then you collect 100 samples and you collect it before and after, and you say, oh yeah, it worked. It reduced it or not. And we could have been looking at 30 years ago at something that was, whatever example you want to think of, but something that was 50 that reduced to 40. And you're making conclusions that the reduction was 10 is good. Mm-hmm. But nowadays, when we apply statistics to it and we apply or consider all these different assumptions, you might realize that 50 is the same as 40, and there's actually no effect. And so I think accepting the fact that science has been part of data analysis, just maybe not used in the past, I think that is the first one. But then secondly, I think the tools that are available today with machine learning, AI, and all that, I think understanding those and using them for the right reasons, I think it helps the overall addressing of it. So the data has always been there. I think the scientific approach is what has changed. And again, I think one of the things that took me a while to grasp the concept of, but I think we finally, as a team also understand it, is there could be interactions that you never thought of before that have an effect on, for instance, microbial outcomes that we didn't think about, but they actually do. And so because think about this, right? If you have a physical process by segregating product that you put aside, In the past, you might just think, well, that has nothing to do with the microbial outcome at the end. Well, it does, because you just took product off flow that you're going to have to ice down. And then you ask the questions: do you ice it down properly? Do you put the right amount of ice? Do you rework it on time? How do you introduce it back into the flow? Do you increase yet another variable to the process that could have an effect on the end result? And so all those things, I typically think that the newer generations are actually getting smarter and smarter and smarter. I see my kids operating a tablet, a cell phone, or a remote control. And I'm thinking that I probably knew how to do that when I was 12 or 13, and this kids could be a year, 2 years old. I had never seen a cell phone in my life at that age. And so I think the new generations bring also a new challenge when it comes to a different perspective and different ways to view the data. And not coincidentally, our data analytics group is very young, but it's always fascinating to work with them and actually come out of these brainstorming sessions where they challenge you more than you challenge them, because we might have all these burdens in our heads that we grew up in this business, but they come in clean and they understand this data analysis. They understand microbiology, food safety, and it could be a good dangerous. And so that has been absolutely fascinating to see how we evolved to where we are today. And just thinking again, I made the joke earlier that when I look at Excel, I'm thinking that was the past. That's the way we analyze things in the past, comparing column A with column B. But now with the graphs that these teams are producing, when you look at Excel, it looks like a 1-year-old came up with these graphs. And so I think is more than the change is like a mindset change in this position to understand that the new way to analyze data is completely different than 10, 15, 20, 30 years ago, especially in our business.
So you kind of actually started answering my next question, but where are we going in the future? Like, what's looking ahead? How are companies that want to be on the cutting edge, how are they shaping the future of food safety using these different technologies?
Yeah, so I definitely think, and the first thing that comes to mind is that I definitely think is going to be predictive analytics. Unfortunately, for instance, you cannot predict when you will have the next positive or this particular level of, for instance, salmonella. You can't. I can't just tell you today you'll have this, but predictive analytics can give you the tools to get you to at least send out a signal that you could be at risk for all these different variables that are occurring around you. Now, in microbiology, you're always going to be behind because, again, you get results, the best case scenario, after 24 hours, maybe 48. But like I said at the beginning, if we don't consider the other factors that could potentially be affecting an outcome, like a microbial outcome, we're going to be missing out. And so I think a combination of all environmental factors, processing factors, things that we can obtain from the machines that we use, whether it's an auto deboner, whether it's an X-ray, whether it's a metal detector or a bone detector or whatever. I think that if we can collect all that, if we can collectively put all that together with historical data that we have, I believe that an outcome can be predictive as a risk. Not necessarily you will have it, but under today's conditions, your risk is high. Now, I believe that that's in the near future. I think at some point, and I could definitely see that before I retire, that I think there's going to be not only this is your risk, but these are the potential solutions to mitigate that risk.
Sure.
And so, and again, with the evolution of AI and machine learning, I think that is something that is not far-fetched. It's something that is going to happen. We just got to be able to embrace it believe in it and understand that is a helpful business decision. And so the times of that you have a job, add to your job analyzing the data are gone. I mean, we got to be able to use the people that are trained and capable of utilizing the tools that are available to do data analysis, so that we can make a strategic decisions based on those. And I think there's going to be a lot more of that coming up. So I do see the near future where there's going to be lots of data analysts, especially in QA and food safety. And at some point, there's going to be like a network of these data analysts that are just going to be taking us to the next level. And I know we talk about risk assessments as something that is a strange, or I need to get this one person to come in and do a risk assessment. But I think an everyday real-time risk assessment is something that is in the works. I mean, it's already happening. We can use it. We just need to be able to welcome it. Of course, there's a lot of security concerns that need to be addressed. And so that's why I always say that all those got to be blessed and vetted by an IT department, somebody that knows about that. But the tools are there. And I think the future is here in terms of data generation. I do proudly say that we are 100% paperless in QA and food safety. All of our checks are digital. We don't have any clipboards with papers laying around where we're writing information down. Everything is on a tablet in a digital form. And to me, that's the only way to do a real-time analysis, where you have things on digital forms. But again, we just got to accept the fact that it's here. And I don't think we need to resist to it.
Yeah. So when you think about like strategic partners that you may want to do work with, or your future business impact, how do you pick these partners? How do you measure the impact? If something's been positive or negative, like kind of big picture.
I would say that I'm definitely looking for somebody that would accept my craziness, and not just mine, but the one of us as a group, as a team, thinking of what else and how else can we do something. But I think in the world that we live in today, especially in the line of business that we do, the first thing in mind is sense of urgency, understanding that some of this testing that we want to do, some of this hypothesis that we want to prove, they can't wait. We can't just be out there for 2 months or 3 months. We need an answer now. And on the craziness arena, I would definitely say the thinking outside the box, because we can't continue to think traditionally what we've done in the past. We can't just think that testing an intervention or testing a process needs to be before and after. We just got to get it out. And then being able to find solutions together, to me, is something that I continuously look in a partner, whether it's a molecular diagnostic company or a manufacturer vendor for a piece of equipment. And I typically appreciate those who can also provide resources for in the statistical side. I mean, I do have a team. But I want to partner with others that look at it completely different. That they don't look at our business day in, day out. They can also come up with some of these solutions and some of these strategies to analyze data outside of the box, outside of the norm. And so I would say that those 4 things, summarizing them, is a sense of urgency, thinking out of the box, and finding a solution together and providing resources is to me what I look for in a partner, because I'm going to say that I like to be pursued rather than pursuing. And so, if I need to wait for something, to me, that relationship is not going to work. It needs to be more of, we're in this together. Let's put in 100%. Let's put our brains together. We all going to benefit from this. And let's just think about what kind of projects can we work together to prove certain hypothesis. And we also got to be adults enough to understand that when the outcome is not what we expected, we need to drop it and move on to the next one, rather than trying to prove something just because I think it works. But there's one point that, again, I'm not against testing things multiple times, but there's a point that you just got to make the decision and say, well, let's just move on. We've done so much of this, and we've done a lot of those. I would say in the last 4 years, we've done a lot of those. Some of them work really good, and some others just didn't work out. And again, I'm open-minded. I'm okay going back to the drawing board and see how else we can tweak things to run another test. But sometimes running the same test over and over and over again when you don't have the results is just not the right answer.
Yeah. Do you have an example of a favorite problem or just a solution that was solved by a data-driven decision? Like, do you have like a major win that you just, those?
Yeah, it was, and I'm going to try to protect the identity of the innocents here, but there was a project that we were thinking for about close to a year at how we can solve a particular problem relating to microbial light independence, and we were just brainstorming about it. And so we partnered with this molecular diagnostics company. We had great people that work there. They're top notch, super smart, and very impactful. And we went on to a brainstorming session with nothing on the table, but just a bag full of dreams and what we wanted to accomplish and how we think we could do it. And we sat down, laid on the table. Well, not on the table. We actually wrote on a board in this beautiful, beautiful sunny day in the northern part of the U.S. And in the drawing board, we just going at it. What we think we could do, how we can get it accomplished, and all that. And so this was around, I would say February, the end of February, super cold. And when we finished going through all that, and there was a lot of back and forth in terms of how much data are we going to need, what are the resources that we're willing to invest in this, and how far are we willing to go, and I was very passionate about what I wanted to accomplish, and the hypothesis that we had in mind. And somebody at the end of that meeting, before we left, they asked me, so when do you want to get this done? And so usually what I say is that for somebody with ADHD like me, you can't just ask that question because the answer is going to be yesterday. But I basically said, I still remember vividly that I said, I would like to have data to be presented the second week of April. So we were just talking about a couple of months. And so if I had a camera, I would have captured the beautiful moment of everybody's faces, that their jaws were dropped thinking that, oh my gosh, this is not going to work. But what amazed me about this particular company is that they didn't blink. It was like, okay, after a big swallow there, it's like, okay, I think we can make it work. We will make it work. And my team executed flawlessly and partnered with them, and we partnered with a university, and we executed, and we actually had results that I was able to share with some colleagues in the industry, and from there, I believe that was the first attempt to solve something that we wanted to solve, and from there it's just been a snowball effect in a positive way, because we've been able to add new things and change things, and I think that helped a lot. Not only to our company, but for the industry, in looking at how we can partner together with somebody like this organization to address some of these data needs and some of these questions that we have that have not been proven before, or that we want to prove one way or the other. And so that to me was very satisfying. But again, I think it boiled down to this particular company raising their hand and saying, I'm here, I hear you, I understand what you want, and let's just partner together and let's just work it out. And I think that is the best success story I have. And I'm still happy about that today.
It sounds like you should be proud. The wins are, you got to roll on them sometimes because they don't always have wins.
It's time for our famous three. Boehringer Ingelheim develops poultry vaccines of unparalleled quality with a focus on prevention and control across a wide range of diseases. We deliver unique, sustainable solutions for broilers, layers, breeders, and turkeys. Our veterinary network brings unsurpassed knowledge and experience, helping producers make smart, innovative, science-driven decisions to improve bird health and performance. For more information, visit poultryhealthusa.com.
Well, before we wrap up today, I want to ask you the questions that we asked all of our guests. And the first one is do you have a favorite poultry-related resource that you use in your job or in the industry daily?
So I don't typically read printed copies of things. I'm more of a digital guy. And I don't have any one in particular, but every morning, I go to the gym first thing in the morning, but before I go, I read through, I glance through all these different magazines that send information as they send their briefs, and they have these highlights. And so I love to do that first thing in the morning. That way my brain is fresh and is just looking at what's going on. So I keep it that way. So, I mean, I don't have one in particular. I hate to mention one and leave the other ones, but I go through 3-4 of them regularly, and I do get, of course, from a lot of my colleagues and friends, they'll send me links to things that they read or a paper that just came out, because I think in this world and in this line of business, it's all about relationships, and so I get a lot of information from different sources too, and that helps a lot. It allows me to dig into some information deeper. And what I like about it is after I learn about it, I forward it to my team because I want them to read about it, know about it. And in my mind, that's a way to just stay connected.
Yeah, definitely. Second question is, do you have a favorite non-poultry related resource that you reference or have read or listened?
Yeah. So I mostly listen to podcasts about Portuguese just because I like the language, and yes. I like to listen to Portuguese podcasts that have nothing to do with poultry. But recently I got really hooked into this book, Ultra Processed Foods, and it's just been fascinating to go through. Again, I'm surprised about myself because, like I mentioned, I don't usually read printed books or things like that. It's all digital, but this one is very special, and it has really impacted me a lot. And I'm not even halfway through, but I just started it, and it's been a fascinating read.
Yeah, it sounds like a good recommendation for anyone looking.
Yeah, for sure.
The last question is, what is your best advice to be successful in the poultry industry?
So this is not verbatim or literally mine, but the most impactful phrase that I got, and I try to live by that, is somebody that a former boss gave me once, and that is, do your job. Sometimes, and I know that's simple, and that sounds a bit like, well, what's going on here? But it's got a lot behind it, though, because a lot of times we focus on the wrong things. We focus on what is the next job. I wonder how much this person is making. I wonder if there's another position that makes more money or less money, or I wonder, what's going to happen here in 2 years? How much longer am I going to do this job? Is it okay to do it for 3 years or 4 or 5 or 1 year? And so I think a lot of times there's a lot of distractions. And so those distractions prevent us from doing 100% of our job. And so I truly believe that you need to focus on the job that you have on hand and work on it and believe that you will never master it, because there's always something that you're gonna have to that you're gonna learn, something that you need to do, and if you believe that you got it all figured out, that is the worst lie you can tell yourself. But
Yes.
but I do tell that to younger generations, even my kids, my older kids that are in working age and about to start the workforce. I tell them that don't worry about the rest. Don't worry about the money. Don't worry about, you need to worry about doing your job. And if you do your job, good things are going to come out. Of course, the environment has to be right? I mean, that's what I just said is not absolute. If the environment is not right, then you need to find a different environment. But at the same time, when the environment works and the environment is healthy, like the environment I worked at, and I've worked for the last 21 years, when you do your job, there's others that are going to see that. You don't need to be doing, you don't need to be showing off for people to realize that you're doing your job. And so it goes both ways. But again, in general, on a healthy environment, focus on your job and nothing but your job, and try to support the whole organization. I think that's the best advice I can give.
I think that's great advice, and simple advice doesn't mean it's easy, right?
That's right.
There's a lot of hard stuff. Oh, well, thank you so much for talking with me today. I think I definitely have a greater appreciation of the depth and complexity of just asking a simple question within the great land of food safety, keeping our protein source definitely safe, and so people can keep eating yummy chicken.
Thank you. I appreciate it. And this has been great. So really thank you.
You're welcome. And for those of you who are listening, if you like this, share it with your buddies so they can also listen some great information. Thank you.